Hi guys, this is Miss Pruitt and I wanted to bring you a video on the basics of trigonometric functions and how to, of course, graph them. What I want to start with is the sine graph. Alright, so let's go ahead and get started. So, if we're talking about graphing a trigonometric function, starting off with sine, these values that we're going to use derive from our unit circle. Remember our unit circle? There are major points of this unit circle that I want us to focus on. And there are these 4 points right here. So let me remind you about the values around the unit circle and what everything means. Starting here, this would be 0, and I'm talking about radians. All these are in radians. At the very top, we have pi over 2 radians. And remember, we're going in a counterclockwise direction. So if I keep going from the pi over 2 down here, this value was pi. And if we keep going down here to the bottom of the graph, I don't know why I put 2. It's 3 pi over 2. And then if we keep going back up here to 0, we have gone the distance of 2 pi radians. So at each one of these points, there is an ordered pair. If this is my origin, of course we know about our origin, right? The distance from the center of the circle here was 1, 0. Going around here at the very top, the coordinates at that point, we're going 0 on the x-axis, right? But we're going up positive 1. Over here, the coordinates for this point is negative 1, 0, right? Keep going. The coordinates for this point were 0, negative 1. And once again, going all the way back up to 2 pi, those coordinates are the same. And going around and around and around the circle, these points just repeat. So one of the special things about the unit circle is that the x value all around the unit circle for the ordered pairs is going to be cosine of whatever radian you're at or degree. And the right-hand side of that ordered pair would be the sine of that radian. So we're going to use both this unit circle and the fact that the left-hand side is cosine, the right-hand side is sine, in order to complete the graph for y equals sine of x. So let's put our x values right here. Let's put our y values right there. I know that I am concerned about when x equals 0. And I'm talking about radians. And going up to the next important value, when x equals pi over 2. When x equals pi. When x equals 3 pi over 2. And also when x equals 2 pi. So going around the circle, we're just going to look at what we have and try to fill in this table. So at x equals 0, we're right here. I want to know what the sine of this point is. Well, you look at your ordered pair. I have 1, 0. This is going to be my sine because the right-hand side is my sine for that radian. So sine of 0 degrees is going to equal 0. And I'm going to put that right here. Next, go up to pi over 2. Again, I want to know what the sine of pi over 2 is. The sine of pi over 2 is going to be this right side of my ordered pair, so it's just 1. Keep going. What about pi? So I want the sine of pi. All you got to do is look right there. That's the answer. Put it right there. Keep going. 3 pi over 2. I want the sine of 3 pi over 2. Well, looky here. It's right there. -1. And if I'm going all the way back around, I'm back up here. Use a different color. I still want my sine of x. It's still on the right-hand side. The answer is 0. So, using what I have on this table, I'm going to plot my points. So, we should know that the center is the origin, of course. Let's make this pi over 2 to pi. Let's make this 3 pi over 2 to 2 pi. And if we're going the opposite way, then this would be, oops, screw it. This would be -pi over 2 and -pi. -3 pi over 2 and -2 pi. All right, let's graph this thing. So put a point at 0, 0. Boom. At pi over 2, I should be up at 1. Oh, yeah, we didn't mark those, right? That, of course, is 1. And down here, that'll be -1. Boom. Now, that means that at pi over 2, I need to put a point. At pi over 2, I'm going to go up to 1. Put a point. At pi, I'm at 0. At 3 pi over 2, I'm at -1. And at 2 pi, I'm back at 0. So, if I'm connecting these points with smooth curves, not with points, that's how you graph sine. Now I can keep going, and I should keep going. That's just what this graph does. It keeps going. Actually, it's going to keep going that way also. So, that's my graph of sine of x.